Hey guys, welcome to Learn Today IGCSE. This video is a tutorial for Physics Paper 4 Theory version 4.2 for May-June 2023 examinations. Question 1 A. Figure 1.1 shows a helicopter which is stationary at a height of 1,500 meters above the ground. Part 1. State the two conditions necessary for the helicopter to remain in equilibrium. Well, to answer this, we first need to understand what is meant by equilibrium. Equilibrium is when a body or object is either at rest or moving at a constant speed in a straight line, meaning that all the forces of this object must be balanced. So the first condition is the resultant force must be zero, or you can write no resultant force. And the second requirement for an object to remain in equilibrium is that the turning effect of forces must also be balanced. So we can write this as resultant moment must be zero or no resultant moment. Part 2. The mass of the helicopter is 3,200 kilograms. Calculate the change in the gravitational potential energy of the helicopter as it rises from the ground to 1,500 meters. The formula to calculate the GPE is mass times gravitational potential energy times change in height. The mass is given here at 3,200 kilograms. G is the acceleration of free fall, 9.8 meters per second square, and h is given as well, which is 1,500 meters. So it is giving a value of 4.7 times 10 to the power of 7 joules. Do not forget to write your units in joules. Question B. Figure 1.2 shows a vertical speed-time graph for a parachutist who jumps from a stationary hot air balloon. The parachutist jumps from the balloon at time 0, here, and reaches the ground at B, here. The point A indicates when the parachute opens. Part 1. On figure 1.2, label a point on the graph where the acceleration is 0, label it with 1. When the acceleration is negative, label it with 2. And when acceleration is decreasing, label it with 3. To answer this, let's look at the trend of the graph first. We can find the acceleration using a speed-time graph by looking at the gradient of the graph. So as you can see here, at the beginning, the gradient is like this, and then it's like this, and it reaches a horizontal trend. So if you look at the gradient over time, you will see that it started off like this and gradually decreased. So if the gradient is decreasing, this means that our acceleration is also decreasing over time. So the point where the acceleration is decreasing can be labeled somewhere here. And when gradient is horizontal, it means that there is zero acceleration. For zero acceleration, we will label it as 1. There's also another horizontal gradient here that you can also label as 1. And for acceleration being negative, it means that they want you to find the deceleration of the parachutist. Deceleration means the speed of the graph is decreasing. The gradient here indicates the deceleration of the graph. So you can label negative acceleration over here with the number 2. Part 2. Explain in terms of forces the changes in motion which occur from when the parachutist leaves the hot air balloon until point A. So the parachutist leaves the balloon at this point, and until point A is the point where the parachute opens. When the parachutist jumps at this point, the weight of the parachutist is greater than the air resistance, so there will be an acceleration. And as the speed of the parachutist increases, the air resistance increases as well. So now the acceleration would slow down. And next, it reaches a point where the weight becomes equal to its air resistance. We call this as terminal velocity, where all the forces are balanced. So you can use this information to fill out your answer and achieve 4 marks. If you have written your answers differently, that's okay. Just check if you have these key points which I have highlighted to get the complete 4 marks in this question. Question 2. A student catches a cricket ball. The speed of the ball immediately before it is caught is 18 meters per second. The mass of the cricket ball is 160 grams. Question A. Calculate the kinetic energy stored in the cricket ball immediately before it is caught. The formula to calculate kinetic energy is 1 over 2 times mass times velocity squared. The mass is already given here, but since it is given in 160 grams, you have to convert this to kg as this is the SI unit. So your mass would be 0.16 kilograms times with the velocity given, which is 18 meters per second squared. You will get a kinetic energy of 25.92 joules, which rounds up to two significant figures at 26 joules. Again, please do not forget to write your units. Question B. It takes 0.12 seconds to catch the ball and bring it to rest. Calculate the average force exerted on the ball. In order to calculate the force, you should know the formula. Force equals the mass times acceleration. The mass of the ball is already given in this part of the question, which is 0.16 kg. So all you have to do is substitute the value. And the acceleration is not given directly. You have to calculate it with the rest of the information given. Using the formula, acceleration equals to final velocity minus initial velocity over time, we can calculate the value of acceleration. So the final velocity is already given here. To rest means it stopped, so the velocity is 0. Before it is caught is 18 meters per second, meaning that this is the initial velocity. So let's substitute the values. Final velocity is 0 minus initial velocity at 18 meters per second over time, which is given here 0.12 seconds. This will give us an acceleration of negative 150 meters per second square. You can just ignore this negative as this indicates that the ball is decelerating instead of accelerating. So now just substitute the value of acceleration found here into this formula of force. And the value of force will be 24 newtons. The unit for force is newtons and the unit for energy is joule. Please do not get confused by this. Question C. As the student catches the ball, she moves her hands backwards. Explain the effect of this action on the student's hands. Another way of finding out the average force is the change of momentum over time. It's mentioned in the question that it takes 0.12 seconds for the ball to reach the hand. So let's say when the student moves her hand backward like this, she is increasing the time of contact of the ball towards her hands. If we relate this with the formula, this means that if the time increases, the force being applied decreases. So you can write this action creates longer time and therefore reduces the force on the student's hands. You have to mention both the longer time and the force on the student's hand to obtain a full 1 mark here. Question 3. A. Figure 3.1 shows a person moving across an ice-covered pond to reach a ball on the ice. Explain why this way of moving across the ice is safer than walking. Use your understanding of pressure in your answer. When the person is horizontal like this, the force of the person is being spread out over a much greater surface area to when they are walking. We know that pressure equals to force over area. The force here being the weight of the person, which remains same. But as the area increases, the pressure exerted on the surface area decreases, so the ice is unlikely to crack. Question B. Figure 3.2 shows a side view of the pond with a layer of ice floating freely on the water. You have a few information given here stating that the surface area of the pond is 5 meters squared, the mass of the ice is 690 kilograms, density of water is 1000 kilograms per meter cube, and point X is 0.45 meters below the ice. Calculate the pressure at point X due to ice and the water. Okay, the pressure experienced at point X is due to the pressure of water and the pressure due to ice. So in order to calculate the total pressure at point X, we can write a word equation like this. We have two relevant formulas to pressure. The first one being pressure equals to force over area applied for solid. And the second one is pressure equals to density times gravitational acceleration times height, which is usually used in liquid or gases. So in order to calculate the pressure due to ice, we are going to use the formula pressure equals to force over area. We are given with the mass of the ice, which is 690 kilograms, and the surface area, which is 5 meters squared. So let's use this to calculate the pressure. Force over area. The force here is equivalent to its weight, and to calculate weight, it is mass times gravitational acceleration, which is 690 kg times 9.8 meters per second squared, over the area of the ice given is 5 meters squared. You will get a value of pressure for the ice, which is 1352.4 Pascal. Now let's look for the pressure due to water. To calculate the pressure due to water, you have to use the formula density times gravitational acceleration times height. So the density of water is given at 1000 kg per meter cube, gravitational acceleration is 9.8, and the height is 0.45 meters, giving you a pressure due to water at 4410 pascals. Now we can add up the pressure due to ice and the pressure due to water to get the total pressure at X, which is 5762.4 pascals. I'm going to convert this into a standard form, giving me 5.8 times 10 to the power of 3 pascals. Question 4. A. The temperature of a fixed mass of gas at a constant volume is decreased. State and explain in terms of particles how the pressure of the gas changes. Molecules in a gas are in constant random motion at high speed. So random motion means that there will be collision with the walls of its container or with other molecules. The collisions with the surface of the walls of the container creates pressure. So when temperature increases, the molecules of the particles moves at a higher speed, which leads to more collision with the walls, creating a higher pressure. And when temperature decreases, the molecules move at a lower speed, meaning that there will be lesser collisions with the wall, creating a smaller amount of pressure. So that is how the pressure of the gas would change when the temperature decreases. Question B. Part 1. State the value of absolute zero in degrees Celsius. The value of absolute zero in degrees Celsius is negative 273. Part 2. Explain what is meant by the term absolute zero and refer to particles in your answer. Absolute zero is the lowest possible temperature at which particles have the least kinetic energy. For 2 marks question, you can also mention that this is the lowest possible temperature. Question C. Cylinder 1 contains 300 centimeter cube of gas at a pressure of 9 times 10 to the power of 4 Pascal. The gas is transferred to cylinder 2 and the pressure increases to 1.6 times 10 to the power of 5 Pascal. The temperature remains constant. Calculate the value of cylinder 2. Okay, just stating out all the information given, and this is what it looks like. According to Boyle's law, the relationship between the pressure and volume for a fixed mass of gas at constant temperature can be written as P1V1 equals to P2V2. 1 represents cylinder 1 and 2 represents cylinder 2. Now let's just substitute all the values given. To find V2, just rearrange the formula and you will get a volume of 200 centimeter cube. Question 5a. Figure 5.1 shows an electric heater used to heat a room. The dimensions of the room are 4.5 meter times 6.1 meters times 2.4 meters. The density of air is 1.2 kilogram per meter cube. Part 1. Show that the mass of air in the room is 79 kilograms. They have given you the dimension of 3 values. This means that this dimension will give you the volume of the room, which is 65.88 meters cube. They have given you the density of air, which is 1.2 kilogram per meter cube, and they just want you to prove the mass is 79 kilograms. So this formula should be in your mind right away. Density equals to mass divided by its volume. To show that the mass of the air is 79 kg, just rearrange it and it's density times volume. Substitute the values and you get a mass of 79.056 kilograms, which is 79 kilograms when rounded up to 2 significant figures. Anyway, both answers are acceptable. Part 2. The power of the heater is 1100 watts. The specific heat capacity of air is 1000 joules per kilogram degree Celsius. Calculate the time taken to increase the temperature of the air in the room from 16 degrees Celsius to 20 degrees Celsius. When the question asks you to calculate a value, you need to know the formulas related to the information given. There is only one formula related to specific heat capacity, which is energy equals to mass times specific heat capacity times change of temperature. Just a reminder, you will always be given with the specific heat capacity of a substance, so you do not need to memorize any values. So from here, we are able to calculate the energy. The mass has been obtained from the first part of the question, which is 79 kg, times specific heat capacity given, which is 1000 joules per kilogram degree Celsius, and the change of temperature is from 16 to 20 degrees Celsius, which is 4 degrees Celsius. From here, we can get the change in thermal energy in joules, which is 316,000 joules. But the question wants you to calculate time and has given you the power in watts. So from here, you need to have the ability to find the formula relevant to power, energy, and time, which is power equals to energy multiplied by time. Since we are looking for time, just rearrange it and it's power divided by its energy, and you will obtain a time of 287.27 seconds. Which written as 2 significant figure will give you 290 seconds. Part 3 suggests one reason why the time calculated in Part A2 is the minimum time needed to increase the temperature of the air in the room from 16 degrees Celsius to 20 degrees Celsius. In real life, there could be thermal energy lost to surrounding in the form of being transferred to objects in the room or through the windows or doors. Question B. Figure 5.2 shows a cross-section of a double-glazed window in the room. You have an outer glass plane here which is made of solid and a narrow air gap in between the glass pane. State the main methods of thermal energy transfer from the room to outside which are reduced by this type of window. Okay, we have three types of thermal energy transfer, which is conduction, convection, and radiation. Conduction only happens through solid, convection and radiation happens through fluid, which is liquid or gas. So the thermal energy being transferred from the room to outside through this window means that it goes through this solid phase, which is through conduction, and then passes through the narrow gap, which is through convection. Despite of only 1 marks given here, you still have to write both the methods of thermal energy transfer.